Welcome back, everyone, to Merge Conflict, your weekly developer podcast, talking about all things in the world of technology. I'm your host, James Montemagno, and with me, my other co-host, Mr. Frank Kruger. Welcome back, buddy. How's it going?
Hello, James. Thank you. It's been a long time. I had to take a little bit of a break from the show. I hate to do it. It happens every year, every 2 years. I don't know. It happens from time to time. Thankfully, you found an amazing guest host to fill in and outdo me because y'all talked about a topic I wouldn't be very good at talking about. So, tricksy little game you played there, Mr. Montemagno.
Can you believe that I got Heather on the pod? I mean, Heather had her own pod, but I actually got her to do a pod. We were debating. Like, she was dreading being, not necessarily being on the pod or having to talk to me for like an hour on the pod, but I think that as managers, we don't get to code as much as we'd like to, but I don't know. What did you think of the discussions that we had in general?
Oh, it was a fun discussion because I guess I still live in a world where um, I've never really been a manager. I've been a tech lead. I've directed teams under me but from a technical level, like assigning work and yelling at people when they didn't get the work done. But I never had to worry about people's careers or their emotional state or really them as a human being. No, I'm just kidding. But, I never really had to be a proper manager, as they say, a people manager. So I actually, I really tuned in to the discussion. I wanted to hear what managers had to say about managing. And
True.
I knew I was in for a good episode. I think Heather said right in the beginning, she's like, "All right, let's talk management. What do you got?"
Cool. She's in.
Ready.
She's ready. She's great. So I really appreciate Heather coming on. If you haven't listened to last week's episode, Heather, my partner, my wife, joined us. Longtime C#.NET developer, so she knows our audience very well. But then also, she became a manager right before me, which was cool because I'm learning a lot from her. We get to talk a lot about stuff, and then kind of sharing a little bit about that was fun as well. So I'm glad that you enjoyed it. And yes, welcome back. And we're getting close to the end of the year, which is kind of crazy because we have this week and then next week's Christmas here, and then this January after that. So boom, boom, we're like holiday episodes. We're dropping on Christmas, dropping on New Year's, welcome, boom. So kind of wild. We'll be here with you the entire step. I hope everyone has some time off on it. But the world of development does not stop for holidays because, Frank, I want to break down 2 and or possibly 3 or possibly 5 different, maybe 10 different pieces of technology that is exciting. And I've had a lot of questions about because I have been recently diving into the world of WebAssembly deeper. And you've been there for a while, but Frank, there's new hotness in the world of WebAssembly. So I want to break down today a deeper dive on the video I just put out on my YouTube about WASI, the WebAssembly system interface, and how it relates to WebAssembly. Obviously, it's in the name, but then also what are the use cases? How is it different than containers, and why people should care about this technology at all in general, right? So let's first break down WebAssembly. If I was editing this video on the YouTube later, they'd be like, WebAssembly, be a cool graphic. So imagine that in your head, blah, 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 WebAssembly, or Wasm as they call it, Frank, Wasm. Yeah. WebAssembly. Yeah, why is it called Wasm? It's
it's not a perfect acronym. It's just WebAssembly. Yes.
Yeah.
Just deal with it, James.
Yeah. So do you want to break down what and how and what WebAssembly is? And people may know of WebAssembly from the .NET world, mostly because of Blazor, but it's not just a .NET-y thing because it's an open standard, and .NET and Blazor are just part of that journey, if you will.
Also, the little library called We, I believe, was first to market as a public release that supported WebAssembly very well.
And
indeed.
Yeah.
Yes. Anyway. So WebAssembly, isn't it wonderful? It's a runtime. In the same way .NET is a runtime, It is a way to execute code within the browser that is, surprise, not JavaScript. Yay, everyone doesn't have to use JavaScript. And I say that honestly, both sarcastically and not sarcastically, because JavaScript is wonderful and everything, but sometimes you want to use other languages, and it's not the easiest thing to compile other languages into. So we were given, the web gods gave us WebAssembly,
Oh,
and thank you, web gods. I think they're in Helsinki. I don't know where they are. Um, uh, it is a runtime, and it is also a programming language. It's an assembly language. You can debate
it's
whether
in the
that's a
name.
programming language or not. It's in the name. Wasm. It's really elegant, honestly. They describe the virtual machine and the instructions. So assembly is usually an instruction, a source of data, and a destination for the data, much like a function would take an parameter as its input and output a result, or take an in-out parameter, whatever. So they're like little functions, but they're baked in. So you can take a programming language like C and compile C to WebAssembly, because it acts just like another machine. It's just another machine. Um, just like a x86 machine or an ARM machine or a PIC micro machine, any of those kinds of machines. And who doesn't love that? There's pros and cons to that approach, but the nice
Yeah.
thing is compiler developers feel right at home, and you can get the most biggest important compilers like GCC, and I think eventually like LLVM, Clang, and all those friends to output this as just another instruction set to those native languages. And finally, here comes the .NET C# people. And of course, we want in on that game, so of course you can compile C# all the way down to WebAssembly. The mono people made it happen because they're like angels to the god of WebAssembly. I don't know. The analogy falls apart.
Yes. So, problem before WebAssembly, there wasn't a way that you could just elegantly run your C#.NET code in the browser directly, right? If you think about ASP.NET Core, you have servers, you're clicking a button, you're going back and forth, have to write a lot of JavaScript. You don't want to write JavaScript. However, you do want to be able to interop with JavaScript. So the thing with WebAssembly is that you can run the WebAssembly side-by-side JavaScript. Like we do this literally all the time in Blazor, right? That's literally how you can invoke into JavaScript. It's in the default templates. And like I think you said is a good example is that you can think of them as like little WebAssembly modules that kind of like get loaded into the JavaScript app. Like there's a wasm.js file that's like doing stuff, right? And the runtime is basically in this host of a browser, right? So I think that's the thing to kind of remember here is like the browsers needed to implement WebAssembly support, right? Just like today, if you wanted .NET to run on iOS or Android or Windows or Mac or Linux, the .NET runtime needs to run on those things. So like somebody has to do work to make it run there. Well, the cool part about WebAssembly is that since it's a standard, a bunch of browsers, like browsers on my phone, WebKit, for example, boom, it can host it, right? And Chrome can do it, Edge can do it, and anywhere. So now wherever you can, any supported browser can run WebAssembly, your C#.NET code can run there, which is like really elegant and really fantastical. And if you want to write JavaScript too, you can, but you don't have to necessarily, but you could.
Yeah. And it's really it's a nice model, because being a virtual machine, we all understand how to compile down to it and make our code run on it. The biggest downside is that it's kind of an isolated virtual machine.
Mm.
It does not have direct access to the DOM, so you can't just mess around with HTML and links and things like that. It has a very primitive memory model. You've got to write a tiny bit of JavaScript in order to provide it memory. There's another big limitation that I totally wanted to mention, and it's completely slipping my mind now. But well, I'll just say it's like there's no operating system there. So there's no
Yeah.
way that it's not like a Unix environment. You can't just open a socket to connect to a website or something. The best you can do is bridge yourself up to kind of the JavaScript, or in our case, the Blazor C# world, and then let other browser features do all the heavy lifting of establishing sockets, what drawing to the screen, playing
Yeah.
audio, the normal multimedia things that you want to do in an app. Touch events, you gotta write that bridging layer yourself, or use an awesome library like we or Blazor to do all that stuff.
Exactly. Yeah. And a lot of the, Blazor libraries, right, that are out there will do that bridging back and forth. And you're right about the DOM. That's where things can get scary. If you have stuff in JavaScript that's modifying the DOM or wanting to modify the DOM versus like you're trying to modify the DOM, like who's controlling the DOM and the shadow DOM and all this other stuff. Right? So it gets a little bit tricky. And there, so it's not perfect solution, but it does solve a use case and has been growing in popularity because, like you said earlier, it's not just C# and .NET. It's all sorts of different programming languages that are out there. You got the Rusts of the world. You got the Go's. You got the other things that are out there. There's all the programming languages want to be part of it. And to me, that's pretty cool, especially if you were in a big company and you had a lot of different teams working on different things, using different programming languages or collaborating with different people. You could just jam some stuff together. Now you got a whole big world of WebAssembly goodness. Because it's like you said, you're compiling the thing into WebAssembly and executing it.
Yeah, and you can use web workers, so you can get real multi-process stuff happening too. I like to try to run neural networks in the browser, and we take full advantage of web workers and WebAssembly to accomplish that. The WebAssembly, because high performance numerical libraries tend to be written in C, so you have to compile them into a form that can run on the web. And then I believe it's still a single-threaded model, but WebAssembly it's a moving target. It's well implemented, well supported,
Mm-hmm.
but it's also growing. So it's gaining features all the time. As far as I know, it's still a single-threaded model, and so the trick for that is you spin up 10 or 20 web workers, each executing a WebAssembly, and all of a sudden you have a a 20 process machine, concurrent machine, communicating through the DOM of all god awful things to use for that. Um, and that's your synchronization mechanism. And surprisingly, you can build incredibly powerful things with that setup.
Yeah. And you can build entire web applications that run 100% offline, no server in between. And that's
Mm-hmm.
what some folks need use cases for. Now, Frank, the
Mm-hmm.
problem with this is that you need a browser. What if you wanted to execute your WebAssembly outside the browser?
That just no, don't, because it's too hard, James. As someone who has implemented several virtual machines and programming languages, it's too much gosh darn work. Don't do it. I guess if someone actually asked me, okay, I wrote an app in this, but I want to turn it into like a native app or something, we give them the normal advice. You write a native app, you put a web view in it, and you shove all your code into that web view, and bingo bango, there's your app. Which is honestly a very valid way to write apps. Don't let my tone of voice lead you off. Go
No.
ahead and do it that way if that brings you happiness. But are you saying there is an alternative, perhaps, method?
Yeah, I think of this away from the UI world. And I got a lot of questions of this on my video, which is like, well, oh yeah, what do you mean? Like, what is there like some UI stack or blah, blah, blah? I'm like, no, don't think of it like that. Think
Mm-hmm.
about of it as logic and functions and web work and not web workers, but workers and
Yeah.
HTTP servers, things that don't require a UI necessarily. Now they could be invoking some
Mm-hmm.
things XYZ in there, but imagine you want some workers that are interacting with something and you just want to execute these things or functions that happen. Now you might say, well, okay, well, James, wouldn't I just write that in C# and .NET and then I would just like run that where C# and .NET run?
Mm-hmm.
Sure, absolutely. You could do that. In fact, you could also, you know, put that into a container, right? If you want it to be modular, right?
Yeah.
And then you say, okay, now I container, I got a host OS, I got the runtime, I got the container D, I got all this stuff inside of it. So you can do that, so there's these different aspects that are in there. But if you think about a WASM, piece of code that you have, like a function or a HTTP server or a worker or something like that. If you think of that as a module, right? Like I want to take that module of code and I want to be able to execute it and run it anywhere, right? Now, this might be places where .NET doesn't run today, right? It might be some crazy embedded system. It might be some specific Linux distro. It might be, who knows what it might be, right? Or it might even be somewhere that .NET is running, but you don't want any bits of the .NET runtime or any of the compilation there. You don't want to create a container. You don't want the overhead of it. What if you just had the Wasm code module, like executable basically, and you could run it on a Wasm runtime that basically ran everywhere? That means if you can compile your code, whether it's Rust or Go or C# or .NET into Wasm, then you don't need to worry about runtimes and different containers and different images and different formats. As long as you have anything that can have a host for Wasm or a Wasm runner, then you could execute it. And that's one problem with it, right? The other problem is basically having system access, right? Wasm today, WebAssembly doesn't have system access. It's in a browser, right? So what if you want to access the file system across all these devices and all this, the network and all these other things? You need some interface that could be implemented by the runner that could handle this stuff. And that is where WASI comes in. It's the WebAssembly System Interface that, for all intents and purposes, is a set of different system interfaces and APIs and methods that need to be adhered to have those system level accesses for WebAssembly code to execute. So that means if you have functions and methods and HTTP servers and all this stuff, you can compile it into a WebAssembly module and then execute it anywhere at all, right? Anywhere in there. So it's kind of similar to like Containerd in a way, if you were comparing that to Docker and all this stuff. Like it is kind of maybe like that. That's maybe how I would put it there, right? So what's really neat about that is that us as .NET developers, right, we can kind of have this model and then compile the code, and we can compile it in now many, many ways, right? We can just bundle the runtime into like something with with a UI or whatever, or bundle a full publish, right, and get the .NET runtime that we need. We could put it into a container and do blah, blah, blah. Or we can compile it into WebAssembly and then run that in one of the runners, which supports .NET, for example, which would be, or well, I guess any of them that's out there today. And there's a few of them. But one of them that was in Rich's blog and the one I demoed was a Wasm time, for example. So lots of words,
to it.
Lots of things. So
I really wanted to interrupt you so I could say Wasm time.
Okay, because I'll edit it. So imagine there's a world that did all this stuff. What could that be, Frank?
James, perhaps the best named console app I have ever heard of, Wasm time. It's Wasm time.
It's Wasm time. You get it? Like, it's time for Wasm. It's Wasm time. Wah.
At first I was rolling my eyes a little. Let's start with the basics again. So I compiled some code into a Wasm, a Blazor app, a cool C ray tracer, something, into a .wasm file. Now I can just run it at the command line because I'm a command line junkie. I like that.
Yeah.
I don't have to bring up a browser, remember the crazy JavaScript or anything to enter into it. It will just magically run because someone thought to use an interface file instead of whatever, the browser thing. This is super cool. I'm super excited for this. I don't know if I personally am going to have any direct needs for it or anything, but I was like, I'm not sure I'm going to use this until I found out the command line app is again named Wasm time. And so for sure, I will at least tonight be compiling something so that I can run some Wasm time. Like you said, yeah, this is just the example runtime for running at the command line. You could embed this thing in a million different things in a million different ways. Very cool. So really what I would say is Wasm is growing up. It's broken it's left home. It's left the browser, and it's just here in the world, I guess. I want to talk about all the stuff you said about containers, but mostly just one last time. I just want to say Wasm time.
Wasm time. Yeah, I think the other part too is like, Wasm time has like a security, or Wasm has like a WASI, I should say, Web Assembly System Interface. Is as a security model around it as well. So I think that is pretty unique. I obviously, when my video showed just kind of running it locally, running it on Wasm time, whereas like I could give anyone in the world, or I could go into any Linux distro, I could just have Wasm time there, and then I could be executing that Wasm module. And that could be a Wasm module that's in Rust or C++ or Python or Go or .NET. And I could just run it, you know what I mean, without having to install any of the bits or other things or anything like that. And I also don't need the .NET runtime to be there to execute it, because Wasm time is handling executing the Wasm code, which is quite brilliant in many instances of it. So again, as a .NET like iOS and Android developer, I'm like, oh, do I need to go, like, what am I going to do with this? Well, it's not really maybe the use case for it, but I'm thinking like embedded systems, and I'm thinking maybe in the future of how I do want to execute code on the server, for example, and put code on the server. It might be a different way of 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 uh, of kind of bundling up my application as an
Yeah.
option. Yeah.
Yeah, it would honestly be kind of nice if Unix apps were shipped as little WASM files, because
Mm,
then you would have a little bit more control over the runtime environment that they're executing in. As it is, like a lot of Unix scripts are in a scripting language, but it's kind of nice that these are compiled down. Um, yeah, I wonder if that for that reason it won't be taken off in the open source world where everyone does like all their not compiled things. People aren't used to distributing .o files or object files or .a files. Usually just kind of ship around code.
yeah.
Anyway, super cool. I am curious which parts of the operating system WASI covers. I've been trying to click through the documents. You might have seen my eyes bouncing around,
Yeah.
but it's a little hard to get through it, seeing which API exactly they provide. But I do want to actually mention a clarification on something I already said earlier. I said I wasn't sure if Clang, LLVM's C compiler, was supported under WASM, but the WASI SDK, WASI-SDK on GitHub, specifically uses Clang as the compiler for the
Mm,
WASI SDK. And I just thought that was interesting because I think it was GCC that had WASM support first. Again, if you're using .NET, you don't have to worry about any of this. It's built into .NET. But I do have a lot of C code that I like to compile as WebAssembly, so that's why it just caught my attention. Oh, I can use Clang now, and it does support some Unixy features. I'm sure it just generates a whole bunch of code to talk to the WASI interface. But very cool to see this world really evolving.
yeah. It's neat. Yeah. Basically, what they're doing, and we'll put a link to Rich's blog post, but what they're doing is they have this .NET.WASM, which is, for all intents and purposes, the .NET runtime in WebAssembly that's needed for the app. And then they can load your module and it can handle that. So that's going to enable you to execute your .NET code side by side and like handle all this stuff for you. So it's really, really neat. And like, he talks about a bunch of different scenarios and also the speed of them as well, which is pretty fast. We're
Mhm.
talking, in some cases, if you use WASM plus native AOT support, which is supported in this, which is
I
crazy.
was about to ask you.
Yeah.
I was gonna bring
Uh,
up that joke. James, is native AOT supported? Of
it
course.
is, funnily enough. It can be faster than the core CLR alone, which is kind of crazy. The native AOT is still
Mhm.
like the fastest, which makes sense, right? There's still some layer there,
Mhm.
but it's actually like pretty crazy fast, which is kind of bananas. But, he talks through like, okay, like we could be doing converting different like markdown files into something else and like outputting them to disk or whatever. We could create a little HTTP server that is like processing some stuff and just like running on some server or whatever. You know what I mean? Like small little
Yeah.
things that are out there. So it is really, really new. But again, it is, for all intents and purposes, kind of cool that there's actually WASI experimental support in .NET 8. So it's a .NET .8 workload, and you say .NET
Oh, I
workload
see.
install WASI dash experimental, and you get it if you just have .NET 8 stable release there. So they shipped it as a
Oh,
experimental workload, which is cool.
well, this is news to me. I think we should that's super cool. So there is a new workload named WASI like hyphen experimental. Is that like part of the version number, or is it just it's part of the name? WASI hyphen
Dash,
experimental.
yeah, dash
Yeah.
experimental.
Okay. Super cool. I will definitely try that out because I don't know. I totally dig this for like console apps and things like that. I don't know why.
Yeah.
Same reason you like .NET because it all bundles together. You can do the same thing. You can get .NET to bundle into a .exe, that contains everything that you could possibly want. It's kind of fun to have like a whole different bundling technology available to us.
Yeah. Well, and that's what I think is pretty neat about it is that you don't have to worry about where it's at or how it's running. Just like here's my files, just like execute that
Yeah.
stuff. Again, it's like, I think that um while today there's the SDK has some different support for like where it's going to run and all the other stuff, it's going to give you more support for those other things like threading and all this other stuff and just different scenarios. I think as a .NET developer, I'm thinking, well, I might not need any of this, but I might, someone else in my company might need it, or someone else might need a use case, right? Like have .NET part of that journey, I think is really exciting to see. You're like kind of moving forward and being part of this kind of next generation of early things. It's like, I don't know, crazy experimental new things on the internet, you know, just to kind of see .NET part of that is pretty cutting edge, when you think about it.
Yeah, especially when you started bringing up the container speak, I was like, "Oh, way to bring cutting edge to cutting edge." We always have to mix our domains and everything. But again, I think it's just kind of the beauty of .NET also that it is it's been a pretty fixed runtime for several years now, and that runtime's been able to be ported to other runtimes very easily. So it's just kind of it's nice that we're always able to take advantage of these new platforms and things like that. So just another little shout out to .NET for having a good design that's easy to port around when these kinds of new things pop out. Still waiting for my .NET native AOT GPU converter. Just tell your friends that stuff. That there are other platforms out there. Web GPU is out too. This isn't the only way to run native code on the web. So
Yeah.
I want some .NET love there, but yeah, absolutely. It's always fun to see .NET not just keeping up with the technologies, but in a way, like it defined this technology of uh, okay, Java too, hi Java, Java and .NET defined this technology of a tight little executable that can be run on any platform. And the web has gone full circle from just being in the web browser and now onto machines. And it's nice to see that we're all just getting along and we're not drawing any like turf lines or anything crazy like that.
Yeah. I agree. And I think that there's a lot of additional new innovation that we'll see. In fact, at Build this year, Mark Rusinovich did this presentation. This is linked to in Rich's blog. It's very slightly mentioned, but basically there's this part of the presentation called the Hyperlight. And Hyperlight is a new hypervisor. It's lightweight and secure, and it's basically a
Mm.
Wasm enabled cloud, if you will, of hypervisors being able to run Wasm and doing this stuff. So they demonstrate Blazor running in this new sort of lightweight hypervisor and
Oh.
spinning up like I think he spins up thousands of these hyperlight hypervisors in milliseconds, basically creates them and starts them and runs them because they're so lightweight and doing this all in this sort of WASM enabled, and they're all compartmentalized, right? They're super secure
Right.
little things, which is very fascinating in general. So yeah,
Yeah,
to see that's cool.
and that's the part I kind of jumped over because at first I said my eyes were rolling back when you said containers. I'm like, oh, whatever. It's a packaged up little executable, but I guess we call those containers now, which is super cool because
Yeah.
They are so lightweight that you can orchestrate them. You can kind of create more reliable systems. It's kind of the Erlang lifestyle, lots of small processes communicating with each other. And maybe you do it through a HTTP server. Maybe you use something fancier. But as far as I can tell, like the WASI protocol just implements good old sockets, good old Unix sockets, and all the other protocols are built on top of those. So it's a pretty developer friendly world that we can live in there too for doing our communications between little containers. But
Yeah,
it is fun to see the container world embracing web technology. There just aren't any borders anymore, James. We're all container app web developers now. I don't know
it's
what
true.
anything is anymore.
Exactly. It's a world I want to live in. Everything's everywhere all the time. Everything all at once everywhere. It's great. Yeah. Cool. Anyways, that's
Uh,
mostly all I wanted to talk about. I did a
wait,
short little 9-minute video, but that's all I have. What else do you have?
well, I have the most fun little factoid also to
Ooh.
just really heighten this discussion here. The .wasm files, those are binary files. You can't like drag them into a text editor. They look like garbage. Don't do it. But did you know there is, of course, a text version of WebAssembly files? Because, of course,
Oh.
you can get an assembly dump from an assembly. Do you know what the file extension is for those files?
No, what is it?
.wat. Watt. It's
Ah,
just
good old WAT files. Yeah.
it's just a lovely file extension, and I insist that everyone distribute their WASM files as WAT files because it's way cuter than .wasm.
Brings me back to my, I think, Doom days, right? Everything was a WAT file, wasn't it?
Those were WADs.
WADs.
It's
Oh,
you
those guys.
gotta place your tongue slightly differently in your mouth to say the difference. With my lisp, you can't tell.
There you go. That's funny. It's cool. Yeah, I mean, there's a lot of stuff out there too. I think it is evolving. Like they're technically WASI is like a preview one. That's what this is on. Like I think they're even saying for .NET 9, they'll just only be on preview 2, right? So it's
Is that
evolving
right?
over
Okay.
time. Yeah. But there are other things out there already. Like there's WASI SQL, so you can kind of get like SQL support and things like that on it. There's all sorts of other stuff like that's inside of it. So kind of cool.
Yeah, as far as I could tell, it was just file system and sockets, so communication and storage. I did
Hmm.
not see threading, so I'm curious if they will ever have a threading model, or if they're just going to embrace the multi-process style of just spin up another process for every WASM.
Yeah. I'm interested to see how it evolves over time. But I wanted to give a little bit more detail. I had a lot of questions about it. I'll link to it, all the
Hmm.
things and stuff like that. But if you want to see it in
Cool.
action, check out my YouTube video. Only 9 minutes. You can skip to the demo part. I have chapters on there. Just go there. So it's neat because
Well,
the runtime, like the host OS and the runtime, like when you export those out, right? The actual like when you're CS proj, it's actually like Wasm WASI or WASI Wasm basically,
okay.
and it's
Yeah.
like WASI is like the host OS and Wasm is like the what is it? Let me look at it again. Yeah, the OS description is WASI, and then the OS architecture is Wasm basically.
Yeah.
So yeah,
Okay.
it's kind of cool.
Well, thanks, James, for introducing me and I imagine others to a hot new technology. We all
Yeah.
love hot new technologies.
Hot technology. Well, let us know what you think. You can write into the show, go to mergeconflict.fm, or if you're on YouTube, which is youtube.com/at mergeconflictfm, you can leave a comment on this video where Frank and I put out those videos and we do stuff. So that's super cool. But that's going to do it for this week. We'll see you all for the last episode, Frank, which is episode 390, which means we just do lightning topics. That'll be easy peasy for the holidays. And then we're like 2024. So hope everyone has a great holiday. If you like this podcast, you can do stuff. And that's it. It's going to do it for this week. So until next time, I'm James Montemagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.